Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to APSAC's online support program. Class 9, week 16, chapter number 5, subject chemistry, prepared by Maryam Qureshi. Textbook chemistry, page number 89 to 97. Unit number 5, physical state of matter. Topic included in this chapter are Boyle's law, Charles' law, evaporation, vapor pressure, boiling point, sublimation, and types of solids. Objectives. By the end of the lesson, students will be able to know about evaporation, vapor pressure, boiling point, sublimation, and types of solid. Means I will discuss the above topics in this lecture. Evaporation. Definition. Conversion of liquid into gas or vapor at all temperatures is called vaporization or evaporation. Or you can say that evaporation is a type of vaporization. Vaporization means formation of vapors that occur on the surface of a liquid as it changes into the gas phase. In particular, the process by which liquid water enters the atmosphere as water vapor. Evaporation is a phenomenon which doesn't depend on temperature. Evaporation occurs at all temperatures. It is independent of temperature. How it occurs? When the molecule of a liquid collide, they transfer energy to each other based on how they collide with each other. When a molecule near the surface absorbs enough energy to overcome the vapor pressure, it will escape and enter the surrounding air as a gas. Means when the molecule of a liquid collide with each other, they exchange energy with one another, and when the surface molecule attains or gains sufficient energy, then they start escaping from the surface of liquid. That process is called then evaporation. Means liquid starts converting into vapors. When evaporation occurs, the energy removed from vaporized liquid will reduce the temperature of a liquid, resulting in evaporative cooling. Means evaporation is a cooling phenomena. Evaporation causes cooling. Why the evaporation causes cooling? Because the molecules which are escaping from the liquid gains the energy in the form of heat from the liquid molecules, and as a result the temperature of the liquid decreases. So because of evaporation of the molecules from the surface of a liquid, the heat energy of the liquid decreases. So that's why evaporation causes cooling. Evaporation mostly occurs from the sea and from vegetation replenishes the humidity of the air. This means that the evaporation occurs from the surface of a liquid, from the surface of water and from the aerial part of the plant. Means the evaporation, but evaporation from the aerial part of the plant is called transpiration. As you learned about transpiration in bio, that it is the evaporation from the aerial part of the plant. Vapor pressure. Definition. The pressure which is exerted by vapors of a liquid in equilibrium with its liquid is called vapor pressure. It relates to the tendency of particles to escape from the liquid. Actually, vapor pressure is the measure of extent of vaporization of liquid molecules. A substance with a high vapor pressure at normal temperature is often referred to as volatile. Those substances which vaporize at normal temperature means that they have high power of vaporization. They have greater ability to vaporize because even at normal temperature their vapor pressure is high. So that's why such type of substance which have high vaporizing power we call as volatile. The pressure exhibited by vapor present above a liquid surface is known as vapor pressure. Means the pressure which is exerted by vapors. As the temperature of a liquid increases, the kinetic energy of its molecule also increases. As the kinetic energy of the molecule increases, the number of molecules transitioning into vapor also increases. thereby increasing the vapor pressure. Means when you increase the temperature, the kinetic energy of the molecule increases. As a result, the escaping ability of the molecules from the surface of a liquid increases. As a result, more vapors form and more vapors apply more pressure. That's why with an increase in temperature, the vapor pressure increases. Condensation of a vapor to form a liquid or a solid is the reverse of vaporization, and in the process heat must be transferred from the condensing vapor to the surrounding. The amount of this heat is characteristic of the substance and it is known as heat of vaporization. In simple words, you can say that the amount of heat which is released when the vapors condense is called heat of vaporization. Look at the picture. Here you can see two phases, gas phase and a liquid phase. When you increase the temperature of a liquid, the liquid molecules attain kinetic energy and start escaping from the surface of a liquid. After a short time, then they condense and come back to the liquid surface and apply a pressure on the liquid, and that pressure is actually called as vapor pressure. Come towards boiling point. Definition: the temperature at which the vapor pressure of a liquid is equal to atmospheric pressure is called boiling point. Vapor pressure, all of you know very well that the pressure which is exerted by vapors on liquid is called vapor pressure. Now when the vapor pressure of a liquid is equal to atmospheric pressure, then the temperature of a liquid at that time is called as boiling point. Boiling differs from evaporation. Evaporation is a surface phenomena that occurs at any temperature in which molecules at the liquid escape as vapor because there is not enough liquid pressure on the surface molecule from all sides to hold them. What does it mean? Actually, evaporation is the escaping of liquid molecules from the surface because the in case of surface molecules the attractive forces are not balanced, so they can easily escape from the surface of liquid when they gain a little bit more energy. In contrast, boiling affects all molecules in the liquid, not just those on the surface, because molecules within the liquid change to vapor, resulting in the formation of vapor bubbles within the liquid. Boiling is not a surface phenomena. In case of boiling, not only the surface molecules convert into vapors, but also the molecules within the liquid start converting into vapors, and because of conversion of bulk molecule into vapors, bubbles form within the liquid, and when bubbles formation start within the liquid, then we say that liquid start boiling, and the temperature of a liquid which we provided to it at that time is called as boiling point. Keep in mind, boiling point depends on atmospheric pressure. When you increase the atmospheric pressure, the boiling point will increase, and when you decrease the atmospheric pressure, the boiling point will decrease. Like for example, we say that 100 degrees centigrade is the boiling point of water, but 100 degrees centigrade boiling point of water is at 1 atm pressure. When you increase the pressure like 2 atm, then water boils at 120 degrees centigrade, and when you decrease the atmospheric pressure, then water will decrease at lower temperature. So boiling point depends on atmospheric pressure. It changes with atmospheric pressure. Come towards a sublimation. As you learn about boiling point, melting point, freezing point, evaporation, vaporization, etc., but sublimation is a new term for you. So let's start with definition. The process of conversion of solids directly into vapors without passing through liquid phase is called sublimation. Sublimation is what? Sublimation is the conversion of solid molecules into gas molecules. Sublimation is caused by the absorption of heat, which provides enough energy for some molecules to overcome the attractive forces of their neighbors and escape into the vapor phase. Since the process requires additional energy, it is an endothermic change. When you, in some cases, when we provide energy to the solids, then the solid molecules gain that sufficient amount of energy that they convert directly into vapors without passing through a liquid phase. That process is called as sublimation. The term sublimation refers to a physical change of state and is not used to describe the transformation of a solid to a gas in a chemical reaction. For example, the dissociation on heating of solid ammonium chloride into hydrogen chloride and ammonia is not a sublimation but a chemical reaction. Similarly, the combustion of candles containing paraffin wax to carbon dioxide and water vapors is not a sublimation but a chemical reaction with oxygen. Sublimation is actually a physical change, means in which the physical state of a matter changes. Like when you take the crystals of iodine and you heat it, and the solid crystals of iodine convert into vapors of iodine. Then the means the solid iodine is converted into gaseous iodine. Only the state of iodine change, not the it's that is called a sublimation. But in chemical reaction, when the like for example, when ammonium chloride convert into hydrogen chloride and ammonia, ammonium chloride is a solid and hydrogen chloride and ammonia is a gas, so that is not the sublimation. In sublimation, the molecules remains changed, only the physical state of matter or that substance change. Same like that when in case of paraffin wax, when paraffin wax convert into carbon dioxide gas and water vapors, that is not a sublimation. That is simply a chemical reaction in which solid is converting into gas. In case of sublimation, only the physical state of a substance will change, not the chemical composition of the substance will remain same. Look at the picture. Here you can see the summary of all the phenomena which we already discussed. Here you can see three states of matter: solid, liquid and gas. When solid converts into liquid, that is called melting. But when liquid converts into solid, that is called freezing. When liquid converts into gas, that is called evaporation, or and the temperature at that point is called boiling point. And when gas convert into liquid, that is called condensation. But when solid directly convert into gas, then that process is called sublimation. And when gas convert into solid, then that process is called deposition. Types of solid. Here we discuss only two types of solid: crystalline and amorphous solids, and also the difference between these two types of solids. Crystalline solids. In crystalline solids, the atoms are arranged in regular three dimension, while in case of amorphous solids, atoms don't have a regular arrangement, means the atoms don't have a regular three-dimensional arrangement in case of amorphous solids. Crystalline solids have sharp melting point. Sharp melting point means that fixed melting point. Crystalline solids always melt at a specific fixed temperature, while the amorphous solids have no particular melting point, don't melt at a definite temperature but soften when heated, means they can melt at different temperatures. They have wide range of melting point. They can melt at different temperatures, not the melting point of this amorphous solids is not fixed. Crystalline solids are true solids, while amorphous solids are pseudo solids. Crystalline solids are symmetrical. Symmetrical means that in crystalline solids, the atoms, ions, or molecules are arranged regularly and orderly, while amorphous solids are unsymmetrical. In case of amorphous solids, the atoms, ions, or molecules are not specifically arranged in three dimensions. They don't have a specific arrangement. Crystalline solids are more rigid, while amorphous solids are less rigid. Example of crystalline solids are potassium nitrate, quartz, sodium chloride crystals, etc. Example of amorphous solids are brass, plastic, etc. Keep in mind, quartz and glass are the types of silicon dioxide. Silicon dioxide, the quartz is the crystalline form of silicon dioxide, while the glass is a amorphous form of silicon dioxide SiO2. Recap. Students, in this tutorial we have learned about evaporation, vapor pressure and effect of temperature on vapor pressure, boiling point and effect of pressure on boiling point, sublimation and the difference between crystalline and amorphous solids. Tasks assigned. Solve Self-Assessment 5.3, Self-Assessment 5.4, Self-Assessment 5.5 and Self-Assessment 5.7. Now the chapter 5 has been completed. In the next video, I will start chapter number 6. Okay students, I hope you will learn a lot from this video. Stay safe, blessed and happy. Thank you.